In this video, we are going to be looking at now the paper 2 scope for the 2024 examination as according to the 2024 ATP. We are going to be looking at some 2024 questions coming from the preparatory examination papers that we did this year, particularly the Eastern Cape paper 2 question paper, and then we are also going to include some related example to help clarify every single topic on the scope even further. So we start with a broad outline of all the topics that are going to be on your paper 2 scope. In question 1, you can expect 20% level 1 questions. These are what we call basic questions. We will go further into them soon. And then in question 2, we are looking at maps and plans. In question 3, we are looking at measurement. In question 4 and 5, we are looking at integrated questions, where it's a mix of questions of maps and plans, measurement, and probability. So what can be expected out of the 20% level 1 questions in paper 2? So these are still the basic mathematical questions, but this time we are focusing more on measurement and maps. So basic conversion of distance, mass, and volume, meaning from, in terms of distance, how do you move from centimeters to meters to kilometers. In mass, we are moving from grams to kilograms. From volume, we're looking at milliliters to liters. And then we're also looking at calculating times. We are going to do basic map reading, so being able to identify points in a map and places in a map, and then basic measurement, and then also time in days. So we are going to look at a question to further show you what exactly do we mean. So a popular question when it comes to basic measurement is a question on baking. So here we are looking at question 1. It says a chef prepared a creamy chocolate mousse. Study the recipe below that you used and answer the questions that follow. So we see the ingredients for the mousse, and then we are also having, they also gave us the method of how to prepare the mousse. They're telling us preparation time is 15 minutes, cooking time is 6 minutes, and then that recipe with those ingredients is to serve 4 people. And it says the method: grate the chocolate and melt it in a pot, whisk white egg, powder sugar, cream, milk together until smooth, add the mixture to the melted chocolate, cook for 6 minutes while stirring. And then the last point: spoon the mixture into glasses, sprinkle cocoa powder and almond or vanilla flavoring on top, and chill in the fridge for 1 hour. So all of this is for us preparing the chocolate mousses for 4 people. So keep that in mind. It's only for 4 people. Even the ingredients that you saw before is for 4 people. The preparation is 15 minutes and the cooking time is 6 minutes, and then before you serve it, it has to chill in the fridge for 1 hour. So meaning we are giving it time to set. The first question in 1.1.1 says convert the heavy whipped cream to liters. So our heavy whipped cream is given in milliliters and we have to convert it to liters. So before we do that, let's remind ourselves of how the conversion goes. So the volume conversion says if I'm moving from milliliters to liters, I need to divide by 1,000, and if I'm moving from liters to milliliters, then I'm multiplying by 1,000. If I have liters and I'm trying to move to kiloliters, I will have to divide by 1,000. And if I have kiloliters and I'm going back down to liters, I'm going to multiply by 1,000. So basically, the conversion is all 1,000. The only difference is when am I dividing and when am I multiplying. I am dividing if I'm moving from a smaller unit to a bigger unit. So if I have milliliters to liters, I will divide. And then if I am moving from a big unit to a small unit, I will multiply. So in this instance, I was moving from 125 milliliters. You will see from the ingredients, that's the whipped cream. It's 125 milliliter whipped double cream, and I'm dividing it by 1,000 in order to be able to move to liters. So 125 divided by 1,000 is going to give me 0.125 liters, and that is your answer to 1.1.1. 1.1. So 1.1.2 says determine the number of grams of cocoa powder needed for 12 people. So keep in mind that in our recipe it's considering for 4 people. So that means that we have to increase in order to account for 12 people. So our recipe says 50 grams of cocoa powder. So 50 is for 4 people. So we need to understand what inside the 12, how many groups of 4 can I get? So if I take 12 divided by 4, I get 3 groups of 4. So I'm going to multiply my 50 grams with 3, and then it's going to give me a total of 150 grams. Alternatively, you can just simply take 50 divided by 4 and multiply it by 12. It's going to give you 150, but this method that I have just shown you is the one that's simpler. In 1.1.3 it says determine the total time that it will take to repeat the recipe twice. So our recipe, we were given the time for preparation and the cooking time, and that is if we are doing it once. So it says preparation time is 15 minutes and cooking time will be 6 minutes. This is if I'm doing it once. So basically I just have to add these two numbers, 15 minutes and 6 minutes, and say this is what I'm getting if I'm doing it once, and then multiply it by 2 in order to get it twice. So 1.1.3, I'm going to take the 15 minutes of preparation, add the 6 minutes of cooking, it gives me 21 minutes. This is if I'm cooking it once, and then I'm going to multiply it by 2 in order to get the results for twice, and it gives me a total of 42 minutes. Like I said, these, you can see that this is a basic time calculation that you can expect in your question 1. In question 1.1.4, it says the mousse was ready for serving at 12 or 5 minutes past 12 or 12:05. At what time did the chef start making the mousse? So we know that it takes 15 minutes to prepare. We know that it takes 6 minutes to serve. And then there was a statement, if you go back to the method of preparation, and it says right there at the bottom that you need to have it chill in the fridge for 1 hour before you can serve it. So we can't serve before it chills in the fridge for 1 hour. So we are going to have to consider this in our timing. So basically we have 21 minutes of preparation and cooking plus a full 1 hour of chilling, because they said when it will be ready to serve. We can't serve it before it chills. So basically it needs to set. So 1 hour plus 21 minutes, it gives me 1 hour 21 minutes. So I'm going to take my 12:05 and then minus 1 hour and 21 minutes. Then I'm going to do my basic subtraction, starting with my units at the far right, and then it's 5 minus 1 is going to give me 4, and then I have 0 that I have to minus 2. That's impossible, so I have to come borrow on the side of the hours. So from the 12, I'm going to borrow 1 hour. I'm going to take it to the minutes. When it gets to the minutes, it can't be 1. It needs to be converted to a minute. So 1 hour in minutes is 60 minutes. So I have borrowed 60 minutes. So 60 minutes minus 20 minutes is going to give me 40. On this side of the hours, I was left with 11 hours. I minus 1 and it gives me 10. So my answer is 10:44. In 1.2, it says Mandla lives in Durban and found a new job in Tabanchu, 63 kilometers east of Bloemfontein. The map in Annexure A shows the national roads of South Africa on which Mandla will travel to and from work. It wants you to use the map in Annexure A and the information that has been given above to answer the following questions. So before we go look into our map, remember and keep in mind that it says that Tabanchu is 63 kilometers east of Bloemfontein. So that's 63 kilometers. Keep it in mind. So in Annexure A, we are looking at our map and we can see our national roads. We have your N1, N5, N2, N3, and 14. So those are your national roads, and we can see right there at the bottom that our map is using a bar scale, and we are going to answer the questions that are following with regards to this map. The other thing that is important to note is the N that shows you where north is so that you can know where your east is. That has to be given with your map. So in 1.2.1 it says, choose the two types of scales not used in the map. Write only the letters that represent the correct scales. We had already said that the map we have on the bar we have on the map is a bar scale. So A and C are not the correct scales that we are using. We're not using a word scale, we are not using a ratio scale, because we had already seen that it is a bar scale. And then in 1.2.2 it says, identify the town where the N1 and the N5 join. So we're going to go on our Annexure A. You will see where the N1 starts to join the N5. So it's like it's the N1 that's continuing, but then when it gets to this spot, it branches to the N5. So that's where you can connect to the N5. And what is the name of this town? The name of this town, if you can't see proper there, is Winbeck. So Winbeck is the town where N1 meets the N5. So that is your answer for 1.2. And then 1.2.3 it says, determine the number of national roads on the map with even numbers. So we are looking for the national roads that only has even numbers. For example, we have your N1s, N2. Between N1 and N2, N1 is not an even number, N2 would be our even number. So we are seeing that we have an N6, and then we are also seeing that we have an N8 right next to Bloemfontein, and then right next to Kimberley we have an N12, and then when you go up to northwest you will see that we have an N14. So N6, N8, N12 and N14, those are 4 national roads that are even numbers. Everything else, when you look at it, it's N1, N3 and N5. They are not our even numbers. And then in 1.2.4 it says, if Mandla drives from Durban on the national road and does not turn left on the N8 at Bloemfontein but continues on the N1, what is the first town that he will pass according to the map? So Mandla is coming from Durban. He is not taking the N2. He basically will stay on the N1 and never take the N8. So if he continues with that N1, what is the first town that he will meet? He will meet Edenberg. That town, that little town there, it would be Edenberg. So you will see that he's just continuing with the N1 that took him from Durban and not take the N8 that is at Bloemfontein. So the first town that he passes right after Bloemfontein would be Edenberg. In 1.3 it says Polokwane district municipality supplied 920 schools with 2 tanks of water each to reduce the cost of municipal water bills that schools must pay for water and sanitation. The diameter of each tank is 132 centimeters and the height is 1.5 meters. The tank has a water storage capacity of 2.05 kiloliters. So they have even showed you the eco tanks that are supplied to the school. Pay attention to the units. The units that we've been given are different. Our diameter is in centimeters, our height is in meters, and our capacity is in kiloliters. So there will need to be some conversions there should we need to do some calculations concerning those. So in 1.3.1 it says determine the radius of one water tank in centimeters. So the water tank, it said it had 132 centimeters in diameter, and we are trying to get a radius from that diameter. So how do you get radius from diameter? You take the diameter and you divide it by 2. So radius is equals to diameter divided by 2. Keep that as a formula in mind if you are not aware of it. So then we substitute. Where there's diameter, we put 132 because that's what they told us our diameter was. We divided by 2, it gives us 66 centimeters. Our diameter was already in centimeters, so there will be no need for conversion. The diameter is in centimeters, they wanted the radius in centimeters as well. In 1.3.2, it says calculate the total number of tanks supplied to the 920 schools. So remember, they told us that each school is going to be supplied with 2 water tanks. So if each school is supplied with 2 water tanks and there are 920 schools, what we have to do is simply take 920 and multiply it by 2, and it's going to give you the total number of tanks that we gave to the schools. In total is going to be 1,840 tanks. Details like that are the ones that are very important for you to always remember when it comes to your information. If you have time, I always advise that you read your information twice. In 1.3.3, write down the correct units to measure for volume using only the letters A, B, and C. What is the unit that we use for volume? We know that for area we use squares, so for volume just know that we use cubic meters, meaning everything is to the power 3. And then it says explain in 1.3.4, explain the term diameter. The diameter is the distance from one side of the circle to the other side through the center of the circle. Radius is from one end to the middle of the circle, whereas diameter is from one side to the other side. So it goes from one side of the circle all the way to the other side. So that would be your difference, just in case you get a different question that is now asking you to describe what the radius is. It's from one side of the circle to the center, whereas diameter is from one side of the circle to the other side of the circle. In 1.4, we have Lindiwe. Lindiwe is busy planning for a month of October. The calendar of October 2024 is given below. We see that on the 1st, Tuesday, schools reopen. On the 3rd, it's mom's birthday. On the 19th, she has youth camp up till the 20th. On the 22nd, he has mathematical literacy mock examination. On the 27th, Granny arrives to visit. And on the 31st, Granny leaves. So the information says in 1.4.1, the question rather, write down the number of days Granny comes to visit. We know that Granny came to visit on the 27th and she leaves on the 31st as according to the map. So just as a reminder, go back to your map and you see there on the 27th it says Granny arrives to visit, and then on the 31st it says Granny goes back home. So you count those days, the 27th, the 28th, the 29th, the 30th, and the 31st. And then that would be 5 days that Granny would be at their house. So you are going to include the day that she arrives and the day that she leaves, because she will still be there. In 1.4.2, it says Lindiwe's mom will be 57 years old on the 3rd of October 2024. We saw that on the 3rd, it's mom's birthday. It says determine the year in which Lindiwe's mom was born. So if now it's 2024 and she's 57, you just take 2024, you minus 57, and it shows you that she was born in 1967. Moving on to question 2, we are looking at maps and plans, and under this question we are covering the types of maps that are out there. We are covering how to give direction, meaning your south, east, west. How do you give your direction accordingly according to your compass? And then we are looking at your scales, calculating your scale factor, actual length, map length. We are also calculating distance using the distance formula. We are also calculating petrol cost, because with map questions you will find a lot of questions that people traveling, and you have to calculate their transport cost comparing to the distance that they will be traveling. And then just as we discussed, you're going to have to do your map length versus actual length, know how to calculate that difference. look at a question that will show us what a question in maps and plans is going to look like. We have question 2.1. We have Mrs. Tazibani, who lives in Lesotho and is planning a holiday in KwaZulu-Natal. She plans on going to Vryheid and a few other places. Below is a map that she will use to decide on all the places to visit, and we have a map showing the regions of KwaZulu-Natal. And when you look at the map in full, you can see a clear vision of what the map looks like. We know that our north is at the top as indicated by the arrow at the bottom. So looking at a question 2.1.1 says identify the type of roads indicated on the map. So let's go back to the map and see what kind of roads do we have on the map. Like in the previous question, we are seeing that we have your N2s and your N1s, and we already know from the previous question that we were doing that these are national roads. So we have national roads. That's your answer to 2.1.1. So this is one of those, being able to identify the parts of a map that are essential to a map essentially. In 2.1.2 it says what is the general direction of Vryheid from Lesotho. So we have to stand in Lesotho on our map and try to give a direction of Vryheid using a compass. We have north, east, south, west, and then your north, east, southwest, and whatnot. So we know that at the top is north, is the north, and then when you go to the side, then it's going to be an east. So our direction is northeast. This is how you give direction, not describing how you are going there. Which province, this is 2.1.3, which province is south of Lesotho excluding KwaZulu-Natal? So we are again going to stand in Lesotho and look at a province that we find when we face the south from Lesotho. So when I'm in Lesotho and I face south, I see Eastern Cape. That's the province that I'm looking at. So my answer to 2.1.3 is Eastern Cape is my province. And then in the last question we are looking at 1.2.4. It says the distance from Lesotho to Vryheid is 614.6 kilometers, and Mrs. Tazibani is driving at an average speed of 120 kilometers per hour. Determine how long it will take her to reach Vryheid. Give your final answer in hours and minutes. Basically, the question is asking us to calculate time. However, we are going to use the formula of speed and just manipulate it around, and it will give us the time. So the formula for speed says speed is equals to distance divided by time. So our speed, we know that it's 120 kilometers per hour. Our distance is 614.6, and the time is what we are looking for. So then we make time and take it to the other side of the equals to using a cross multiplication, and we will end up with our distance divided by our speed, and then that's 614.6 divided by 120, and it gives me 5,01266 hours. So the 5 I put aside, and then I plus with 0,1266, and I multiplied by 60y to convert it to minutes. So my final answer becomes 5 hours and 7.3 minutes. In 2.2 it says Mrs. Tazibani has decided to stop in Free State before leaving Vryheid. The car she drives has a fuel consumption of 5.9 liters per 100 kilometers, and the cost of petrol is 24 rands and 45 cents per liter. In 2.2.1 it says give Mrs. Tazibani a clear set of direction to get to Eshowe from Free State, where she plans to spend a day with family before going to Vryheid. Now, when it says a clear set of direction, we are not just going to use now compass direction where we just say go southeast or southwest. We are going to give her direction in accordance to the map. So meaning from this place you will get to that place. So you will describe it in detail, but you have to make sure that as you describe it, you don't just say 10 left. You describe it with the places on the map. So it has to be something that it can be seen. So you see that when you're in Free State, the national road that you have is the entry. So when we describe it, we're saying from the entry, from the Free State, drive on the entry until you pass Pietermaritzburg. So when you go down, you will see that you will pass Pietermaritzburg. Then 10 left on the N2. So when you say 10 left, you have to describe where. Drive until you pass Richards Bay. Then 10 left to Empangeni and continue to Eshowe. So you have to indicate the places that you will pass as she's driving or turning left. And then in 2.2.2 it says determine the number of liters of petrol Mrs. Tazibani will need for a return trip from Lesotho to Vryheid. This is an example of a petrol cost question, except in this one we are only just determining the total liters we will need for a return trip. Return trip means the distance of going and the distance of coming back. So you will see us multiplying by 2 at some point. So we start by taking the consumption of 5.9. That's what it consumes per 100 kilometers. So we divide those two amounts by each other, the 5.9 and the 100 kilometers, and then we multiply everything with the total distance that we need to travel. Remember, the 614.9 is the distance of just going or just coming back. So the total gives me 36.2614. Again, for only a distance of 1, either the going to or the coming back. So we multiply it by 2 to get a double distance, and then the total consumption will be 72.52 liters. And then in 2.2.3 it says hence calculate the petrol cost for Mrs. Tazibani's return trip. We have already determined that the liters we need is 72.52 liters, and then the cost of petrol is 24 rands and 45 cents per liter. So we multiply those two numbers by each other and it gives us 1,773 and 19 cents. In 2.3, Mrs. Tazibani registered her daughter at one of the tertiary institutions in Lesotho. Annexure B illustrates the layout plan of the second floor of the tertiary institution. Use the layout plan in Annexure B to answer the following questions. So now we have moved to plans. Usually when we are talking about plans, we are talking about plan layout of either a school ground, a library. It could even be a train. In this one, we are having a tertiary institution. So we are looking at the layout plan of the second floor of the tertiary institution. So it has also the keys there and also the scale right on top of our keys. They use the scale of 1:350. The first question says, explain the meaning of the given scale. So that scale we were just looking at. What does it mean when our scale says 1:350? So remember, a scale is basically showing us the measurement that we are going to use to draw on paper and the measurement that we will use in real life. So when it's 1:350, it means 1 unit on the map represents 350 units in reality. Because usually when you're planning a house plan, for example, or the institution, that layout of an institution in real life is going to be a big thing. So when you're drawing the plan on paper, you have to shrink it. What do you shrink it? You shrink it to scale. So for every 1 unit, the builder is going to know that I have to use 350. In 2.3.2, it says identify one feature on this layout plot that indicates that this is a multi-story building. Now they already told us this is the second floor, but we are saying, what if they didn't tell you that this is the second floor? How would you know that this is a multi-story building? You look at the keys. In the keys we have a key for an elevator and a key for stairs. Usually when you have elevator or stairs, it's an indication that there is a second floor. So either one of those answers would have been correct. You could have just said elevator or you could have just said stairs. In 2.3.3 it says which entrance is furthest from the library. So we are going to go back to our plan and stand on the library and look at our entrances. So when I'm standing at the library, there's 2 entrances with black arrows coming in. There's a Rock and Villa entrance, and then there's Hatter Street entrance. Hatter Street entrance is the one that is the furthest from the library. So that will be your answer for 2.3.3. Then in 2.3.4 it says determine the number of restrooms available in this layout plan. So you're going to look at for the key of what is a restroom denoted by. Our restrooms are denoted by R. So there is 2 on next to the Rock and Villa entrance and 2 next to the Hatta Street entrance. So that will be 4 restrooms. The next question asks for a probability, and usually that would be given in between question 4 and 5. That would be integrated there, but because this was a September question, it was here, and it says determine the probability of finding a science laboratory on the second floor. So on the second floor we are looking at a science laboratory. We are looking for a science laboratory on the second floor, and as you look you will see that there is no science laboratory. So the probability, you can write it in words as impossible, or you can write it as a number as 0 or 0%. And then in 3.3.6 it says measure in millimeters the length of the south facing wall of the presentation room. So this one would need you to be on paper so that you can take your ruler. So questions like this in your paper, to make sure that you bring your ruler. So you're going to put your ruler on that wall and measure it with your ruler in the millimeter side, and it will give you 34 millimeters. Then the last question says, hence calculate the actual length of the south facing wall of the representation room in meters using the given scale. Give your answer to the nearest meter. So we are looking now, we're calculating the actual length. We know that the length on the map is what we had just calculated, it was 34. Then we multiplied with the 350. Where do we get the 350? Is from our scale of 1:350. It gives us 11.9 millimeters. Then we convert to meters by dividing by 1,000, and it gives us 11.9 meters. They said convert to the nearest, so that becomes 12 meters. Question 3, we are looking at measurement, and you are going to be expected to calculate perimeter and area. You will be given formulas for calculating perimeter and area, so that's not a cause for concern. It's just knowing what to substitute. And then you're going to have to measure measurement costs, ratios, and determine the diameter and radius. In the previous questions we were just describing what they are, but in this one we are going to be doing some calculations to determine what is the diameter and what is the radius of a cycle. And mostly we are going to be focusing on 2D flat shapes, meaning the shapes that are flat. So a circle, a square, and a rectangle. The 3D shapes will be for the question 4 to 5. So let's look at a question 3 question. In 3.1 we have Queen's High School decided to tile a floor of their school hall using a square-shaped dark blue tile. The hall is rectangular shaped. A smaller rectangular stage is located against the front wall of the hall as illustrated in the diagram below. The length of the stage is 10 meters and the width is 5.5 meters. The stage will not be tiled. The length of each side of the tile is 60 centimeters. The school needs to determine the number of tiles needed. So in this scenario we have a school wall that is a rectangular shaped. It has a stage in the middle that does not need tiling, and then we are going to tile them with tiles that are square of 60 centimeters each. So here we have a diagram of what our school hall looks like. We have a picture and then we also have a diagram. So in the diagram you can see that our hall is 18 by 12 meters and it has a stage right in front that is 5.5 by 10 meters. And then 3.1.1 says calculate the area of the floor of the school hall to be tiled considering the stage will not be tiled. So we are looking for the area of the school hall without the stage. So what you're going to have to do is find the areas of both of them and subtract from each other. So let's start by calculating the area of a hall. The area of a hall, area is length times width, by the way. So area of a hall, our length is 18, our width is 12. 18 times 12 is 12 216 meter square, because we are dealing with an area, it has to be squared. And then the stage is 10 and 5.5, so 10 times 5.5 is 55 meters square. And then we are going to say that 216 minus 55 will now give me the area that needs tiling is 161 meter squares only. In 3.1.2, it says the tiler requires 10% more tiles to be purchased to complete the tiling job. And then it has A, B, C. A says calculate the area of one tile that will be used. Give your answer in meter square. Obviously, because we are calculating areas, our answer will be in squares, so that just indicates that we want it in meter square. So we're going to have to convert, because when you look at our information, it told us the length of each side of one tile is 60 centimeters. So the area of a square is side times side. Our side are 60 centimeters each, so 60 times 60 is 3,600 centimeters square. Then we have to convert it to meters, so we divide by 100 square and it gives us 0.36 meters square. So let's talk about this conversion for a second, right? So we know that when we are converting from millimeter to centimeter, we divide by 10. If it was centimeter to millimeter, we would have multiplied by 10. Then centimeter to meter, we divide by 10. Meter to centimeter, we would have multiplied. Then meter to kilometer, we divide by 1,000. Now, when we are dealing with area and volume, because area and volume are squared, you know the units end with square when it's an area. So instead of just dividing by 10, you divide by 10 square. Where you were supposed to use 100, you use 100 square. Where you were supposed to use 1,000, you will use 1,000 square. Similarly, when we go to volume in question 4 and 5, wherever you are supposed to convert from millimeter to centimeter, dividing by 10, you will use 10 cube, 100 cube, and 1,000 cube. So in B, it says hence determine how many tiles must be bought including the extra 10%. So we're now just going to calculate the tiles that we are going to need. Remember, the area that we need to tile is 161 meters square, and then we know that each one tile is 0.36 meters. So what we are going to do to determine that number, we are going to say 161 divided by one tile, which is 0.36, and it gives us 447,222 tiles. Before we convert, we are going to increase that amount by 10%. So we take that amount, multiply it by 10%, and it gives us 44,722. Then we add them together. You only round off at the end, otherwise it will mess up your calculation. So you take the original amount, add with the extra 10% of 44.7, and it gives you 491,9444. Then we round off. Rounding off is going to be 492 tiles needed. Then in C, it says provide one reason for the extra tiles required by the tiler. So this is a general knowledge question. Why would a tiler need us to buy an extra 10%? Is because of in case there's ones that are broken or there is some sort of uncalculated wastage. Then in 3.1.4, it says determine the unit scale used to draw the floor plan. If the length of the wall is 66 millimeters, write your scale as 1:2. Basically here we are trying to calculate a scale factor. So we have been given measurements, meaning the actual length and the map length. So we are going to use those to determine our scale factor. So on the map we are dealing with 66 millimeters. In reality we are dealing with 18. We take that 18 because it's in meters, different units. We need to make sure that they're the same units. So convert 18 to millimeters. You multiply it by 10, that's going to take you to centimeters, and then multiply it by 100, then it's going to take you to millimeters. So 60 is to 18,000. Divide both sides by 60. Why? Because they said on this side of 60 I need to be remaining with 1. Then on this other side it gives me 300. So 60 divided by 60 is 1. 18,000 divided by 60 gives me 300. So 1:300 is my scale factor. In 3.2, Ms. Johnson, the chairperson of award committee at Queen's High, is designing the prize giving certificates for annual prize giving ceremony. The certificate will have a shaded border of 2.5 centimeters as shown in the diagram below. The length of the certificate is 28.5 and the width is 22 centimeters. A performance level circular sticker with a radius of 8 centimeters is placed at the bottom of the certificate. So take note of your dimensions. We have a border that is 2.5, we have length that is 28.5, width that is 22 centimeters, and we are going to have a circle that has a radius of 8 centimeters. Now let's look at our diagram. So we see the certificate, we see the borders that are shaded. Inside there it says that space is 2.5, and then we see the radius of the circle of the gold thing that is in the middle, it's 8 centimeters, and then the length and the width of the certificate themselves. Then the first question in 3.2.1 says calculate the diameter of the circle in millimeters. We were given radius of 8 centimeters. We are trying to use the radius to find a diameter. So it's similar to the question that we did before, where we were given a diameter trying to find a radius with it. So now we are doing the opposite. So to find diameter formula for diameter is radius times 2. So our radius was 8, we multiplied by 2, we get 16 centimeters. Why? Because 8 is in centimeters. Then we have to convert it to millimeters because the question said in millimeters. So we take the 16 centimeters and we multiply it by 10, and it gives us 160 millimeters. So remember your conversion from centimeter to millimeter, it would be times 10. From meter to centimeter, it would have been times 100, and so forth. Keep your conversions in mind. I cannot stress that enough. 3.2.2 says determine the dimensions of the certificate without shaded borders. So basically I'm looking for length and width without the shaded borders of 2.5. So we have to first calculate the length and the width that do not have the borders. So we take, for length, we are going to take 28 centimeters. We are going to minus the 2.5 of the border that is at the top and the 2.5 at the bottom. So 2.5s, and it gives us 23.5. We do the same thing with the width or the breadth. You take 22 centimeters, we minus the 2.5 on the left and the 2.5 on the right, and we are left with 17 centimeters. Basically, this is the length and the breadth of the certificate from the inside when you're not calculating it from the outside. In 3.2.3, it says, hence, calculate the perimeter of the inside without borders of the certificate. You have been given the formula for perimeter is 2 open bracket length times width. So we are going to use the length and the width that we just calculated in 3.2.2, and this is why you have to be careful even in the test, because these questions follow each other. If you got 3.2.2 wrong, it will affect your 3.2.3. So the perimeter is 2 open bracket length times breadth. Our length that we calculated was 23.5 and the breadth that we calculated was 17. Breadth, width, it means the same thing. So you plug all of this in your calculator and it gives you 81 centimeters. We were not told to convert it, so we are just going to leave it as 81 centimeters. In 3.2.4, it says Mrs. Johnson claims that the area of the unshaded part, excluding the border and the circle of the certificate to the nearest square centimeter, is 198 centimeters square. Verify with necessary calculations whether her statement is valid or not. So the questions of verifying the validity of a statement, you're just going to calculate area and just see if you come up with 198 centimeters. So we are going to start by calculating the area without borders. Area without borders, you know, we're using that new length and new breadth that we just calculated. So that's 23.5 times 17, and it gives us 399.5 centimeter square. The square is important because we are dealing with area. And then we are now going to calculate the area of the circle. The formula is pi of 3.142 times radius square. So pi of 142 times 8 square, and it gives us 201,088 centimeter square. Then we are going to take the two areas and have them minus each other, and then we are left with 198,41, and then when you round it off, it's 198. So her statement is valid. Question 4 and 5 are integrated question, meaning that they are mixed. You're going to find a mix of measurement. You're also going to find a mix of maps, and you're also probably going to find probabilities in some of the questions. So you will just find a mix where you will just see I'm doing measurement again, or you're going back to maps, or any variety of those sorts. So what exactly are you looking at? You're going to be required to calculate volume, meaning you're going to be dealing with 3D shapes. You're going to have to calculate total surface area, the imperial system conversion. You're going to also look at packaging, and then you're going to look at the questions that are bringing maps back, and also probability, just as I have said. So let's look at a question in question 4 as an example of what this is going to look like in your exam. In 4.1, it says FedEx Express is an international courier service company that provides rapid, reliable, and time-definite delivery to more than 222 countries and territories. To send a 5 kg box anywhere in South Africa will cost 2,250. The dimensions of the 5 kg box are shown below. It has a width of 17 inches, a height of 17 inches, and a length of 17 inches. So this is a cube, and you are given the conversion that 1 inch is equals to 25,4 millimeters. So our first question says 4.1.1, calculate in millimeter cube. The moment you see cube, you know you're dealing with volume. The volume of a 5 kg box. They have given you the formula for volume. It's length times width times height. So because we don't use imperial system of inches, the first thing that we have to do is take that 17 inches and convert it to our matrix system of millimeters. So we take 17 inch, multiply it by 25.4, and it gives us 431.8 millimeters. Then that 431, we plug it in the formula for volume, and our volume is 80,509,645 and 43 millimeter cube. You will notice that for length, width, and height we use the same number because it's the same 17 inches. We just converted it to millimeters, so we just use it for all of them because it's a cube. All sides are equal. Then in 4.1.2, it says one of the drivers stated that the surface area of the 5 kg box is more than 2 meter square. Verify with the necessary calculation whether the driver statement is valid. Given a formula for total surface area, 2 times length times width plus 2 times length times height plus 2 times width and height. And remember, our length, width, and height are the same number, 431.8. So you plug that number everywhere you see L, W, and H, and all in the end is going to give you a total surface area of 1,118,707.44 millimeter square. They said they want the answer in meters, so to convert, we're going to divide by 10, which will move us from millimeters to centimeters, then divide by 100 to move from centimeters to meters. But the 10 and the 100 have to be squared because we are dealing with area, and then in the end we are going to be left with 1,118 and so forth meters square. We round it off and it's 1,12 meters square. Then in 4.1.3, we are dealing with packaging. It says many of the parcels are transported with an e-transit delivery trucks. Given below are the dimensions of the FedEx e-transit delivery truck. It has a length of 2.2 meters, a width of 1.5 meters, a height of 1.6 meters. The question says, calculate the maximum number of 5 kg boxes that can fit into the delivery truck. So since the width of the dimensions of the truck were given to us in meters, we are going to take our 431.8 that we had calculated as the side of the boxes, the 17 inches that we converted, right? And we are going to convert it to meters. So we divide by 10 and divide by 100, and it's going to give us 0.4318 meters. Then to calculate our packaging, we are going to say length. Take the length of the truck, which is 2.2, divided by the length of the box, which is 0.4318, and it gives us 5.09. And then we do the same thing for the width, 1.5 divided by 0.431, and it gives us 3.47. And then we do the same thing for the height at 1.6 divided by 0.4318, and it gives us 3.71. Then we round off. In packaging, we round off to whole numbers, so everything becomes a 5, a 3, and a 4. We multiply them together, they give us 45 boxes. In 4.2, we have FedEx travels from Detroit to Denver either by truck or plane. The traveling time by truck is approximately 18 hours and 48 minutes. It says at the bottom, study the map above and answer the questions that follow. So we have a map there. So this is that integration that we were talking. We were just doing a calculation in measures, and now we are back to maps. So this is integration of our question. So the question itself, it says calculate the average speed of a delivery truck in miles per hour traveling from Detroit to Denver. This also has integrated the thing of Imperial system, because now we are back at miles, you see, and then the previous question we were just dealing with inches. So our formula says distance is equals to speed times time. The time has to be in hours, and we were told that the approximate time is 18 hours and 48 minutes. That 48 minutes needs to be converted to hours. So we are just going to take the 48 minutes divided by 60 to turn it into hours, and it's going to give us 0.8 hours. So the 0.8 plus the original 18 hours, we have 18.8 hours. Now we can plug into our formula. Our distance was 1,268 miles. The speed is what we are looking for, and our time is 18.8. So we take the speed on the other side by using cross division, and now we have the distance of 1,268 divided by the time of 18.8 hours, and it gives us 67.45 miles per hour. That's your unit there. And then in 4.2.2, it says the flight distance between Detroit and Denver is 1,862 kilometers, which is equals to 1,157 miles. Determine how many kilometers there are in 1 mile, rounded off to 3 decimal places. So what we are doing here is we are understanding that 1,157 miles is equals to 1,862 kilometers. So to get 1 mile, we're just going to take the 1,862 kilometers and divide it by the miles of 1,157, and that's going to give us 1,609 kilometers, rounded off to 3 decimal places. To have YouTube recommend you more of my videos, be sure to click the like button and subscribe to the channel. And if you have any questions, leave them in the comment section below.